impulse invariant transformation and then step invariant transformation again. Which means here the input one will be impulse and then the other one will be step function. Okay. So let's say for the first one you do impulse. Okay. So choose xt equals to delta t because it says use impulse invariant transformation. So xt convert to xx equals to 1. Okay. Why you straight away convert? Because this hs is given in Laplace. So this is in analog form. Okay. So convert straight away to Laplace. So then you can find the output ys, hs times xs. So you get 4 times 1. So then you, after that you will do the partial fraction. Okay. So you do the partial fraction, and then you get one answer, and then you take the inverse of the Laplace function. So you get output yt equals to 4et, 4e minus 2t. Okay. So that's what you do. Okay. Next, or you can use the xn, okay, convert to digital form, okay. So xn convert to delta n, this is in digital form, okay. And then you can find the output from this yt into yn. It's almost the same with this. This is in digital form, that is in analog form, okay. So if it's in digital form, then xn equals to delta n. So this one yn convert to yt convert to digital form, okay. Then after that convert to z transform, okay. Xz equals to 1. Yz will be 4z divided by z minus ets, and then you simplify from these two things, okay. This one convert into z transform, okay. Then after converting to z transform, okay. So the ratio of z transform given the transfer function, okay, yz divided by xz, so you get these two, 4z divided by z minus e2 z minus ets, and then 4z e minus 2z. Okay, so that is one in Laplace transform output result, and then one in this in z transform result. Okay. After that, input signal you change, okay, from xt delta t to xt equals to ut. Then you have xf equals to 1 over s. Okay, so this is ut. Convert to Laplace, you get 1 over s. So times with the hf, and then you do the partial fraction. Okay. After doing partial fraction, you will get inverse. You get this 2ut, 4eut, and 2t. Okay. If let's say you want to start with this is you start with analog. Okay. You convert to Laplace, and then you find the output yt. Okay. If let's say the sample input is in digital form, so then xn will be equals to un, and then from this un you can straight away convert from this yt, you get in digital form yn equals to 2un, 4 nts un, and then this convert directly from the digital table. Okay. And then from there you convert to z transform, okay. Xz equals to z minus 1, okay. And then yz you get 2z divided by z minus 1 minus 4z, and then plus 2z. And then the ratio of z transform gives the transfer function of the digital filter, where hz equals to yz divided by xz. Okay. So this is the final output. This is just to show that it's in z transform function. Okay. So you have two methods there. Okay, one convert into analog. Okay, convert to Laplace transform, get the answer. Okay, and then next you convert sample into digital form. Okay, from digital form you convert to z transform. Okay, and then you get the final output transfer function in z transform. Okay, so just like this table here, okay. Xt, okay, 1 you can use this Laplace and get output yt, and then yt sample in yn, the one straight away to xn, and then convert to xz and yz, and then in the end you get xz. Okay, so this is what I show you is following this concept of principle. Okay, so one here to digital, this one convert to Laplace, and then convert to digital, and then in the end you want to get this z into yz, xz. Okay, so that's what you want to do in the final. Okay? Any question on that? Yes?